The London Underground network of trains allows people to quickly and conveniently travel across this sprawling megacity. Most of the 250-mile network was dug using tunnel boring machines, huge mobile platforms that cut straight through the earth. Now they've stretched the network more than 60 miles further in a major expansion. These huge machines work 24 hours a day, 7 days a week beneath the streets of London to excavate the ground and build the concrete tunnel lining. But back in the 1860s, the cut and cover method was employed to dig the underground tunnel, which ran for a mere 3.75 miles. Workers dug trenches by hand, then constructed roofing systems above that could support the weight of traffic passing overhead. Luckily, efforts to expand the underground network into what it is today rely on TBMs, which have somewhat different designs depending on the type of tunnel being dug and the composition of the earth they are digging through. Regardless of the design, all TBMs feature a cutter head at the front and a series of trailers behind that carry the mechanical and electrical equipment. The cutter head carries a large chunk of a TBM's overall workload. An array of dozens of disc cutters continually rotate and dig away at the earth ahead. Pressed against the face by hydraulic cylinders, the loosened material is removed from the cutter head using a screw conveyor, which moves the material through the back and out of the tunnel on a conveyor belt. The tunnel shield is a cylindrical assembly that's pushed forward to secure the excavated area until the concrete tunnel lining is built. The shield also keeps the trailers behind the TBM's cutter head safe from the displaced earth, protecting the sensitive mechanical and electrical equipment on board and allowing workers to safely maintain and monitor the progress of the TBM. Once each section is cut, a concrete ring is constructed in that section. The segments of the ring are brought into the tunnel on flatbed rail cars and lifted into place using a vacuum hydraulic system, then bolted into position. These slightly conical rings are what form the tunnel. An inbuilt laser guidance system ensures the machine remains on course, ending up precisely where it needs to be. When the ring building is complete, the next tunneling phase begins to build the curvy tunnel routes. These colossal machines played a central role in the expansion of the underground and the construction of the new Elizabeth line. Crossrail used two types of TBMs to dig its tunnels: earth pressure balance TBMs and mix shield or slurry TBMs. Each individual TBM weighs around 1,000 tons and spans about 492 feet. That's equivalent to around 14 London buses in length and 143 buses in weight. The TBMs were so massive that they had to be assembled on location. They operated at depths of up to 131 feet and, depending on buildings above the ground and the geology below, they traveled forward at up to 328 feet each week. 6 earth pressure balance TBMs were deployed to carve tunnels through areas with terrain ranging from soft soils to weathered rock. These machines are designed for operation in soft ground conditions, containing water under pressure. They constantly monitor and adjust the pressure inside the cutter head chamber to achieve a balance with the pressure in front of the cutter head. 2 mix shield TBMs were used to drive the tunnels through the chalk soils underneath the River Thames. These machines use a slurry made from a special clay called bentonite to support the excavation phase. The bentonite penetrates the ground and forms a membrane to hold back water. Pressure is adjusted to handle any changes in the soil. At the separation plane, the soil is separated out and removed, and the clean bentonite is transferred back into the slurry. The TBMs worked in pairs to simultaneously dig 2 tunnels to accommodate both directions of train traffic at once, all while ripping through the earth and plowing concrete. These machines are among the mightiest on the planet. Without them, the construction of deep subterranean tunnels like this one would be almost impossible.